Hey guys, welcome to question FM 288 of the Further Maths 4 to 5 study guide. This question reads, a couple visit the Dandenongs and find a rainforest/cave walk with 7 observation platforms, A, B, C, D, E, F, and G, as shown on the graph below, and then we're given a graph that looks like this. The trails that connect platforms A and C, B and E, and also D and E, run underground through tunnels. So we can see here that these paths along here, or these trails along here, are tunnels. Question A says, at first the couple want to walk along every trail only once on an Eulerian trail. Is this possible? So looking at this graph, if we were to look at the degree of each vertex, so we've got 2, 4, 4, 4, 4, 2, 4, we can see that they're all even, which means an Eulerian circuit exists. Now, an Eulerian circuit is a type of Eulerian trail. It is an Eulerian trail that starts and finishes at the same vertex. So, yes, an Eulerian trail does exist, and it is an Eulerian circuit. Question B then goes on to give us more information. It says the couple then remember they're scared of the dark and they don't want to travel through the tunnels. Question B asks, if they want to visit each observation platform on a Hamiltonian path, what are the possible finishing points if they start at A? So keeping in mind we can't use the tunnels at all now, the only place that we can move from A is to B. Now from B we can move to C and then D to G, or we can move from D to C to G. The point here being that the reason that we can't just go from D to G and keep going around here is that once we pass G, we actually can't go back through it to get back. So for example, if we went from B to D to G, we can go back to C, which means that we can't get to E or F, or we can go to E or F, which means we can't go back to C. So it's important that once we go to B, we move to D and then C, or C then D, before moving to G. Now, once we reach G, we can either go F to E or E to F, and whichever one of those we finish at will be the last stop in our Hamiltonian path. So if we go from A to B, D to C to G, we could either finish at E or F. So the possible finishing points are E and F. We're then given a little bit more information. We're told the couple find a torch in their bag and are able to use the tunnels again. They now want to visit each observation platform along a Hamiltonian circuit starting from A. So our last question, question B, was talking about a Hamiltonian path. We're now talking about a Hamiltonian circuit or Hamiltonian cycle. And question C asks us, how many different paths could they take? So having a look here, we've got to start at A. One of our possible paths could be from A to B to D to E to F to G to C to A. So, and then we could also use the reverse of that. So we could use A to C to G to F to E to D to B to A. So that counts as 2 potential paths, even though they use the same series of letters going forward one way and backward the other, counts as 2 different paths. What you'll notice here is that when we're starting these paths, if we go from A to B, we're not going to go down to C, because that would prevent us from getting back to A at the end. So use that to help you figure out how you might formulate these. Another potential path we could use would go from A to B to E to F to G to C, so from G to D to C to A, and of course also the reverse of that. So A, C, D, G, F, E, B, A. All up, that gives us 4 different paths that we could take. No other paths are possible. So guys, hopefully that answers all of your questions about this. If you have any more for us, please leave them in the comments below. Otherwise, I will see you in the next video.